Myself, Sticker from Aero B section, and the topic given for me is Theories of Chemical Corrosion. Introduction. Corrosion is a process of formation of the compound of a pure metal by a chemical reaction between metallic surface and its environment. It is an oxidation process. It causes loss of metals. Disintegration of a metals by its surrounding chemicals through a chemical reaction on the surface of the metal is called a corrosion. Different types of corrosion are three types of corrosion: acidic theory, dry or chemical corrosion, and galvanic or electrochemical. Example: formation of rust on the surface of iron, formation of green films on the surface of a copper. The responsible factor for the corrosion of the metal are the metals itself, the environmental chemical, temperature, and the design. Acid theory. This theory suggests that corrosion of the metal iron is due to the presence of acid surroundings. According to the theory, iron is corroded by the atmospheric carbon dioxide, moisture, and oxygen. The corrosion producers are a mixture of FeHCO3 to 3032, FeOHCO3, and FeOH3. The chemical reactions suggested are the given below. Chemical theory of corrosion. According to this theory, corrosion on the surface of the metal is due to the direct reactions of the atmospheric gases like oxygen, halogens, oxides of sulfur, oxides of the nitrogen, hydrogen sulfide, and the fumes of the chemical with the metal. The extent of the corrosion of a particular metal depends on the chemical affinity of the metal towards reactivity gases. Oxygen is mainly responsible for the corrosion of the most metallic substances when compared to the other gases and the chemicals. There are three main types of chemical corrosions: oxidation corrosion, corrosion of other gases, liquid metal corrosion. Oxidation corrosion, reaction with oxygen. When we say reaction of oxygen, this is oxidation corrosion. Some of the metal directly react with oxygen in the absence of moisture. Alkali and alkaline earth metals react with oxygen at a room temperature and form the corresponding oxides, while some metals react with oxygen at a higher temperature. Metals like Ag, Au, and Pt are not oxidized as they are not noble metals. During oxidation of metals, metal oxides is formed as a thin film on a metallic surface, which protects the metal from the further corrosion. If diffusion of either oxygen or metal is across this layer, further corrosion is possible. Thus, the layer of a metal oxide plays an important role in the process of corrosion. Oxides of PbAl and Sn are stable and hence inhibit further corrosion. They form a stable tighty adhering oxide films. Au, Ag, Pt form unstable oxide layer which decompose soon after the formation of thereby preventing further corrosions. Corrosion by other gases are C1, Ci2, SO2, H2S, NOx. In dry atmosphere, these gases react with metal in the form of corrosion products which may be protective or non-protective. In petroleum industries, at high temperature, H2S attaches steel forming FeS scale, which is porous and interacts with the normal operations. Liquid metal corrosion. In several industries, molten metal passes through metallic pipes and causes corrosion due to the dissolution or due to the internal penetration. Wet or electrochemical theory of corrosion. It is common types of corrosion of metal in aqueous corrosion environment. This type of corrosion occurs when the metal comes in contact with the conducting liquids or when these two dissimilar metals are immersed or dipping partly in a solution. According to this theory, there is formation of galvanic cell on the surface of metal. Some parts of the metal surface acts as an anode and rest of them act as a cathode. The chemical in the environment and humidity acts as electrolyte. Oxidation and anodic parts takes place. It results in corrosion at anode, while reduction takes place at cathode. The corrosion products is formed on the surface of the metal between anode and cathode. Difference between dry and wet corrosion. Corrosion occurs when you talk about dry. Corrosion occurs in absence of moisture. Wet corrosion occurs in the presence of conductive mediums. Corrosion products are produced at the site of corrosion. Corrosion occurs at the anode, but rusted is deposited at cathode. Factors influence corrosion are nature of metals, environment, concentration of electrolyte, temperature, electrode potential, and hydrogen over voltage. Types of corrosion are uniform corrosion, Pt corrosion, explosive corrosion, stress corrosion, selective corrosion, and galvanic corrosion and erosion. Uniform corrosion. This type of corrosion develops as a pit of very small diameter in the order of the micrometer and results in the uniform and continuous decrease in the thickness over the entire surface area of the metal. Pitting corrosion. This located form of the corrosion is characterized by the formation of irregularly shaped cavity on the surface of the metal. The diameter and depth depends on the survey parameter related to the metal and the medium of the service conditions. In fact, these measurements do not make sense because a very deep and isolated pit results only in the small mass losses, whereas a very large number of superficial pits can be lead to the large mass loss. Third one, transregular and interregular interstellar crystalline corrosion. Within the metal at the level of the grain, corrosion may propagate in the different types. It spreads in all directions. Corrosion indirect differently affects all the metal constituents. This is no selective corrosion. This is called the transregular or translation corrosion because of the propagation with the grains. It is not detectable with naked eye but regulated microscope observation, typically at a magnification of 50, with penetrating into bulk of the metal. Integration of corrosion may lead to the reduction of the metallic property of even lead to the rupture of the components. Effluvic corrosion. Effluvic corrosion is a type of selective corrosion that propagates along a large number of planes running of parallel to the direction of a rolling or extrusion. Stress corrosion. This type of corrosion results from the combined action of the mechanical stress, bending, tension, and the corrosive environment. Crease corrosion is localized corrosion in recesses, overlapping zones for riveting, bolting, or welding zones, under joints and under various deposits. These zones are called as surface corrosions. When two dissimilar metals are in direct contact in liquid experience shows that one of the two corrode. This called is galvanic corrosions. Unlike other types of structural corrosion, galvanic corrosion does not depend on the metallic texture or temperature. The zone affected by galvanic corrosion other as finer aspects than the rest of the surface. This is the last known as erosion. Corrosion by erosion occurs in moving media. This type of corrosion is related to the flow speed in the fluids. Thank you.